Continuing the tour of the SMARTFIRE environment, we'll now consider the Dataviewer post-processing tool. First, it's worth checking that your simulation has created the required results for post-processing. Here I'm looking at the folder that I used for the demonstration. This is going to be inside SMARTFIRE Work, and in my case was called Test 2. And inside this folder, the working folder, are all of the files that were created during and for the CFD simulation. You see that there are a number of files with VTK, VTU and WRL. These are the output files from the CFD simulation. The VTK is a legacy format that we will shortly be removing, but the VTU is the most up-to-date format and contains the field data for all of the variables that have been saved. The WRL is a geometry format that contains the surfaces which will actually give the data context. So launching the Dataviewer program from its icon, we get this interface. And the first thing to realize about this tool is it has two distinct modes. The first mode is for a single dataset visualization. This is by loading a case and a geometry file and visualizing directly using the tools on the left-hand panel. But it also has a series mode where a collection of data files can be loaded as a sequence, and the processing will step through all of those data files to create an animation. So first we'll consider the tool used for a single data set. I go to the File option, import the VRML to bring the geometry context in, navigate to my SMARTFIRE work folder and the case folder that I want to load data from, and then choose a dataset that I want to visualize. In this case I'm going to go for the last time step that I simulated, which is 200 seconds. So I load the results at time 200, WRL file, and open. This tool has a similar capability of being able to rotate the display, zoom in, and it's a good idea to use the geometry to get the most meaningful and largest view you can in order to present the results meaningfully. Next stage is to go to File and Open and choose a dataset. I'm going to choose again 200 second VTU, and that data has now been loaded. I can now activate any of the visualization options, and I'll start with the scaler. I tick Show Scaler and choose the variable that I would like to visualize. In this case, I'd like to look at temperature. And you now see that we have a single isosurface of temperature that is the plume coming off the fire. It is possible with this tool to create multiple isosurfaces and to change the value of the isosurface to any particular value of interest. This can be especially useful when you're showing the spatial variation of temperature throughout the whole domain, and using multiple isosurfaces clearly presents where spill plumes are located and the plume high temperatures are. I'm going to do this for this particular case with 4 isosurfaces, and I need to configure each one with the value that I would actually like to visualize. So I'll start with 100 degrees Celsius, which will be 373 in Kelvin. For isosurface 2, I will do 200 degrees, which will be 473. Isosurface 3 will be at 300 Kelvin, which is 573. Isosurface 4 will be at 500 Kelvin, which will be 773. Whilst this current tool is fairly useful for showing the spatial variation, it's not very easy to see through the isosurfaces which are nearer to you. So for this purpose we've added opacity. So if I take the opacity down to 30%, you can now see through surfaces to see those behind. At the bottom panel, we see the color map. This allows you to change how the temperature values or field variable values are converted into colors. If I change this maximum limit to 773 and the lower limit to 373, that means that the entire range of field values that I'm visualizing go between blue and red. Ticking the legend box displays a color key for the currently selected range. There is another way to visualize the data using this scalar variable visualizer, and that is, instead of an isosurface, to choose a cut plane. Cut plane direction is then selected. In this case I'm happy with XY and I want a single cut plane. I'll change the opacity back to 100%, and now I can control the Z position of my cut plane, taking it from the far extent of the extended region and stepping down through the window into the room, through the fire volume itself and to the near portion of the room. The tool also supports multiple cut planes, so I could choose, for example, a ZY cut plane, and again I can move this around to give me 3D context for the data. How you choose to select cut planes or isosurface visualizations will very much depend on the complexity of your data and what you are trying to show with them. Moving on past the scalar visualization, you can look at vectors. If I enable the vector visualization, I can now activate a single plane and move that plane position through the domain. You see that as I move the cut plane through the volume of the fire, we locate the high velocity red flows that are in the ceiling jet and in the plume itself. More extensive but possibly less meaningful is to choose to disable cut plane, and then you see the entire domain of velocity vectors. But unfortunately there are so many velocity vectors, sometimes this is not particularly helpful as a visualization tool. Again, there is the possibility of having multiple cut planes. I've activated a second cut plane in the YZ direction, and I can move this again down into the context of the fire volume itself. Now I'm going to disable the cut planes in order to show the streamline option. Streamlines are essentially massless particles which are released into the flow and will track with the flow velocities to show where those particles would probably end up. In order to do this, we have to add a source of the particles, and we need to move that source to a suitable location. It's not trivial to move the interactors in 3D. So sometimes it's worth choosing the particular direction views in order to locate the cut plane interactors correctly. I'll hide the interactor and zoom in. And these massless particles show some of the complexity of the evolving flow. So whilst the particles are all released into the fire volume, they then track up with the developing plume. They rotate into sealing jets, and then the complicated nature of the recirculating flow in the back of the room is demonstrated with some of the particles heading out through the window and some of the particles recirculating around and then heading out through the spill plume into the outer room and then out into the extended region. This particular simulation doesn't actually have any smoke available, so the smoke visualization is not available. This is a volume rendered smoke visualization that aims to show approximately concentrations of smoke throughout the geometry, if that had been stored. Disabling the streamlines now so that we can go on to the series animated form of display. Clicking on the Series tab, we now have the ability to add files to the simulation. And this can be accomplished by selecting the first file that you want to add, shift-clicking on the last file from the set that you want to add so that they all become highlighted, and then pressing Open. It's worth checking the list to make sure that everything is in order, in case you'd selected them in reverse order or had not selected them all. Once you're happy that all of the files have been loaded, you can then choose a dataset to load in. Whilst the software may have one file already loaded and connected, you now need to be strategic about how you choose one of these data files. Almost always you'll want to choose the data file which has the largest values of interest, so that the scaling is appropriate for all of the lesser or earlier data files. In this case, I can reasonably confidently choose the last data set. That's time step 200, and I load that file. I then need to go back to whatever type of visualization that I want to create for the animated output. And in this case, I will show the temperature again. And I will create several isosurfaces to show temperatures of interest. I set the color scale appropriate to the data that I've selected, and then I set the view orientation and zoom factor so that I see my data clearly. Activate the legend so that you can see the meaning of the color scale. And we will change the opacity slightly so that it's possible to see the isosurfaces through the nearer isosurfaces. You may also like to add a title so that you can remember what it was you were visualizing. And this can be moved and scaled as appropriate. In order to create the animation, you simply need to go back to the Series tab now, and the animation is controlled by this animation section of the control panel. Now, in the case that we have here, the geometry is not changing with time, so we don't need to activate VRML time series, but we do need to give a name to our save and a frame rate. This is the number of frames per second that will be displayed. Now the times are stepping in 4-5 seconds. If we set too high a value here, the animation will be over very, very quickly. It's probably best to keep this relatively low so that each frame can actually be seen as it passes in the later movie player. I'm going to select 2 frames per second, and then you only need to press Create. Now you see the times are incrementing as each separate V2U file is loaded, and then the animation develops as the data from that V2U file is displayed using the settings that we had set up. You see the lowest isosurface spilling into the outer room and out of the window now. And the evolving higher temperatures coming away from the fire. The animation frames were all saved as PNG files, and also an AVI movie was saved. It's now possible to play that AVI movie. Going back to the post-processing data view tool, it is also possible to select to have probes so that you can examine data within the scalar field. You can click and drag the probe around within the domain to view any values. There's also a line probe. Which shows you the color scale through the scalar field. And when the line probe is defined, you can also display a graph for that particular line probe. So in this case, I'm going to choose a resolution of 20 This means that there will be 20 sections along the graph. I'm going to choose the horizontal axis to be the length from end to end. And I select OK, and the software will generate a graph along that path. I can save that data exported as a CSV file if I want to load it into another tool. There are some additional controls for VRML. Looking at the VRML settings, you can change the opacity geometry, and you can change the type of rendering from wireframe, surface, which was the default, or surface plus edges. You can also change the color of the edges if required. This can be helpful for fine-tuning the visualization in the case where the geometry is very complex or the data is very complex. And that concludes the demonstration tour of the DataView post-processing component of SMARTFIRE.